This slidecast will cover the copy constructor, assignment operator, and destructor. We want a copy of an object to be an independent copy, so that after we've copied an object, we can modify one without affecting the other. When we copy primitive types, it's very straightforward. The values are duplicated and placed in the target locations. Okay, we can copy an int or a double. For class types, copying is done with the class's default copy constructor. And here's the syntax for the copy constructor. It's the class name, as with any constructor, and then we take a const reference to an instance of that class. Now the copy constructor, you may not have seen it before, but it exists and the compiler's been making use of it automatically. So whenever an object is passed to a function by value, so if we have a class variable as a parameter to a function, then the class's default copy constructor is invoked. When an object is returned from a function, the copy constructor makes a copy that's returned to the caller. And when an object is initialized with another object of the same class, then the copy constructor is called. Now referring back to our vector class, so a copy of the size t fields, current capacity and num items, it creates an independent copy of those variables. However, when we copy an instance of vector, it just makes a copy of the pointer, the data, and it doesn't create an independent copy of the array. So this picture shows if we had a vector instance v1 and we made a copy v2, you'll see that all the data fields are independent, but the data, it's an independent copy of the pointer, and they both point to a single shared array. Copying a pointer this way is considered a shallow copy. Because the data pointer points to the same single array, when we make an assignment to a location of the array in v1, it also changes v2's array because they're shared. Now some changes to v1 will be reflected in v2, but others will not. So if we add an item to v1 array, then we'll insert this item and it will change num items in v1. It'll be incremented, but num items in v2 won't be changed. So notice if v2 comes along and calls pushback, it would overwrite the 20 with whatever value was added to v2. So we can get some inconsistencies and some unexpected behavior. So we need to create an independent copy or a deep copy of the array so that v1 and v2 point to different arrays, so making v2 a deep copy of vector v1. So in order to do this, we have to implement a copy constructor as follows. So here is the copy constructor for vector that does a deep copy. And you'll notice if we pass in a reference to other is an instance of the vector class, then capacity and num items will get copied. And here we'll allocate a new array that's the same size as the vector from which we're copying from. And then we'll write a for loop to explicitly make a copy of all the items in the array. So with this vector's copy constructor, we'll now have two independent copies of the array. Now an assignment operator should create an independent copy of an object. So an assignment of primitive types is straightforward. We get a duplicate value. For class types, assignment is done by what's known as the assignment operator. And if v1 and v2 are vector objects, then an assignment such as this statement is going to be executed as if it were written this way. So we're going to do the equals or the assignment operation as defined for vectors. And notice the left-hand side vector that becomes the instance upon which we invoke the equals operator, and the right-hand side is passed as a parameter. And we saw this kind of thing in operator overloading back in Chapter 1. Now, every class has a default assignment operator that makes a copy of each data field of the source object and puts it in the corresponding data field in the target object. If the data field's a class type, then the class's assignment operator is used, and the default assignment operator makes a shallow copy of an object, okay, just as the default copy constructor does. So we have to override it if we want to have independent copies, deep copies. So here is an assignment operator that's overridden for the vector class. So it takes a const reference to a vector, and here we make a copy of the other vector. This will be using the copy constructor. Once we make, and the copy here is a local variable. Now this statement is interesting. It's a swap function, and the idea here is we're going to swap the temporary copy that we've made in this function call, and we're going to swap that with self, which means the instance upon which we invoke the assignment operator. And this swap was defined in the last Slidecast, so you can go back and look at it. And it does a deep copy. And once we do this, then we return this. When we do that, the copy is going to be destroyed because it's a temporary variable once we leave this function. When we leave the function, the destructor for this temporary object is invoked automatically by the compiler, and this will delete the old data because we swapped it. Now the purpose of the destructor is to undo what the constructor does. So the constructor takes a block of uninitialized memory and sets it to a known state. When we call the destructor, the object is no longer considered to be in a valid state, and the memory it occupies can be reused for creating other objects. Now, unless we do this properly, we can have memory leaks. So every class has a default destructor, which effectively invokes the destructor for each data field. And for primitive types, the destructor doesn't do anything. A pointer is a primitive type that stores a memory address as its value, and if a class contains a pointer, the default destructor doesn't do anything with it. So if the pointer references a dynamically allocated object, just like the array referenced by the pointer, the data, the memory allocated to that object needs to be freed. So we need to provide a destructor that frees allocated memory when an object is destroyed. So here's an example of a destructor for the vector class. And its syntax is this tilde vector. So just like we use vector for constructors, we use tilde vector for destructors, and in this case we'll delete the memory that was dynamically allocated and assigned to the data. And the destructor body releases the memory occupied by the dynamically allocated array. And that brings us to the end of this Slidecast.